Hello dear learners, welcome back to my channel. In this video, I am going to explain mathematical sciences question paper. Let's start with linear algebra. In the last year 2024, they have asked 12 questions out of 100. They have asked 12 based on linear algebra. So 12 questions into 2, which is 24 marks. Out of 200, you can easily score 24 to 25 marks. Okay. So first question is the eigenvectors of the matrix. You have to find out the eigenvectors of this matrix. So consider this matrix as A, and the characteristic polynomial for this matrix is x square minus trace of A into x plus determinant of A is equal to 0. Hope you people know how to find out trace and determinant. Then back substitute the values. You will be getting x is equal to plus or minus I. So the lambda value is I and lambda value is minus I. These are the eigenvalues. To find the eigenvectors corresponding to eigenvalues, first lambda is equal to I. This is the first case. Okay. So the formula to find the eigenvectors is a minus lambda I into x is equal to 0. Before simplifying this x, for 2 cross 2 it is x and y. For 3 cross 3 it is x, y and z. Before calculating this x, you just compute this matrix by substituting the value of I. So you will be getting this matrix. After this step, you have to reduce that matrix to echelon form. For 2 cross 2 matrix, the leading entry should be 1 and the below element should be 0. This is the reduced echelon form. And for 3 cross 3 matrix, the principal diagonal elements will be 1 and the below element should be 0. Okay. So our intention is to make this element as 0 by taking suitable row operation. So make this element as 0. Hope you people know this method. So accidentally this element is also become 0. Okay. In other matrices it might not be 0, but you have to consider the operation. Then matrix multiplication, you will be getting this one. Here, dear students, always you should take y coefficient as x value and x coefficient as y value. Then compute those two values in eigenvectors v1 corresponding to lambda is equal to I, that is 1 and I. Similarly, for lambda is equal to minus I, you have to find out the eigenvector. Same procedure you have to repeat again. Once again, I am going to explain that just to avoid the x, for x negative values to avoid, I have taken multiply by negative sign. So it will be like this, and y coefficient should be x value and x coefficient should be y value. Okay. So the second question is, which of the following matrix is positive definite? They have given 4 matrices. You have to check for positive definite. Before that, you should be knowing the definition of positive definite. Any 2 cross 2 matrix or real symmetric 2 cross 2 matrix is positive definite if the leading entry is greater than 0 and the determinant value is greater than 0. Let's start it. First one, 1, 2, 3, 4. 1 is greater than 0, the leading entry, and the determinant value is minus 2, which is not greater than 0, so this is not the positive definite. For second option, 1 is greater than 0, but the determinant value is minus 9, which is not greater than 0, so this is not the positive definite. Third one, dear students, here first leading entry is greater than 0, and also the determinant value is 1, which is greater than 0, so that is positive definite. We got the correct option. Just for your convenience, I'll explain this also. First leading entry is greater than 0 and the determinant value is minus 4, which is not greater than 0, so this is not positive definite. The correct option is option number 3. Okay. Let's move on to the next question. Suppose U and W are subspaces of V such that dimension of U is equal to 4, dimension of W is equal to 5, dimension of V is equal to 7. Then find dimension of U intersection W is equal to, what will be the correct option in these 4 options. Okay. So there is one result regarding this formula. Dimension of U plus W is equal to dimension of U plus dimension of W minus dimension of U intersection W. Also, they have given U and W are subspaces of V, so their addition should be also a subspace of V. Taking dimension on both the sides, you will be getting this one, and they have given dimension of V is 7. Call this as star. Later we will be using this equation. Okay. So now again consider the formula and substitute the values. You will be getting this one. This is one relation. Star, in star, substitute the value of dimension of U plus W. Do you recall this star equation? Dimension of U plus W is less than or equal to dimension of V, which is 7. So this is star. So by that equation we got some more calculations, and after simplification you will be getting dimension of U intersection W is greater than or equal to 2. Clearly we know that dimension of U intersection W is less than or equal to minimum of dimension of U and dimension of W. They have given the values in these two, the value is 4. So this is less than or equal to. Similarly, here we have got greater than or equal to 2. So dimension of U intersection W lies between 2 and 4. For your convenience, I have taken this interval. So let's check the option. 4 belongs to this interval, so this is correct option. 5 doesn't belongs to the interval. 7 doesn't belong to the interval. 1 doesn't belong to the interval, so the correct option is 4. Okay. So the next question is based on linear transformation. Let T be a linear operator on R square defined by T of x comma y is equal to 2x minus 7y, 4x plus 3y. Then the matrix representation of T relative to the basis B is equal to 1 comma 3 and 2 comma 5 is. These 4 matrices they have given, and they are asking us to find the matrix representation using this linear transformation. Okay, let's solve this problem. Very easy and most expected question from this topic. So given transformation and given basis, using this basis element, first element, and apply the transformation, you will get this one. Okay, consider the second element, apply the transformation, you will get this element. Just take this as x and y value and substitute here x and y values, then you will be getting this. Okay, so you will be getting this one. Next, consider that value T of 1 comma 3 is equal to minus 19 and 13, and write the basis element into a linear combination of these two. See, A of 1 comma 3 plus B of 2 comma 5 is minus 19 and 13. After simplification, you will be getting two equations. After solving those two equations, you will be getting A value and B value. So the first column we got as 121 and minus 70. As soon as you got the first column, check for the options. If it is getting the correct answer, then no need to proceed with the second column. Just tick the first correct option and then move to the next question. Okay, so here it is 121 and minus 70, here it is 121 and 70, but we have got minus 70, so this will be the correct option. No need to solve for second column. Then the next question is, for real symmetric matrices A and B, which of the following is true? AB is equal to, this is the direct question, so third one will be the answer. How? Based on this result, you can check. If you want to solve this problem using examples as A matrix and B matrix, then please consider as I matrix or minus I matrix or 0 matrix. If it is not possible to solve with these matrices, then you have to select some other common matrix. Okay, so just read the thing, you will understand. See, which of the following is a subspace of vector space R3 over R? This is very important. Over which field they are asking, that is very, very important. Okay, so W is equal to x comma y comma z belongs to R cube, and here they have given such that y is equal to x square. W is equal to set of all x, y, z belongs to R3 such that x minus 4y plus 5z is equal to 2, and also these 4 options they have given. First of all, I'll give you a shortcut tip, that is, inequalities are not considered in subspaces or in a set. Okay, so this is obviously not a correct option, and here it is not linear, so it is not a correct option. And for these two options, we have to check for whatever the values of x and y and z, if you consider whatever the values of x, y and z, you will not be able to get 2. For example, simply if I take x is equal to y is equal to z is equal to 0, then you can't be getting 2. Okay, so this is the correct option. If you want to go through the definition, then this is the definition. 0 vector is in W because 0 is the positive identity, additive identity. Closed under vector addition, closed under scalar multiplication. Also, I have given some tips for you. Y is equal to x square, which is not linear. If you consider this as first element, this as second element in W, then if we add these two, you will be getting this one, which is obviously not following the condition. This is x and this is y and this is z. Y is equal to x square. This should satisfy, right? But this element is not satisfying this condition, so it is not a subspace. For this, if you take x is equal to y is equal to z is equal to 0, then it will give 0, which is not equal to 2. So this is not a subspace. Inequalities are not considered. So this is the correct option, because if you take x, y and z is equal to 0, then you will be getting 0. So the next question is, the row space of a 20 cross 40 matrix A has dimension 14. That is nothing but the rank. Okay. What is the dimension of this space of solutions of Ax is equal to 0? They have given the options. Using rank nullity theorem, rank of A plus nullity of A is equal to n. What is n here? The right side of the order of the matrix, that is number of columns. Okay, so for back substituting in the formula, you will be getting 26. That is the correct option. Rank of A they have given, right? 14, which is in coded language, that is row space. That is nothing but rank. And this is also a repeated question in KSET. If A is 2 cross 2 matrix over R with determinant of A plus I is equal to 1 plus determinant of A, then what will be the correct answer? Trace of A is equal to 0, determinant of A is equal to 0, A is equal to 0, determinant of A is not equal to 0. Since they have given the 2 cross 2 matrix, the eigenvalues will be lambda 1 and lambda 2, right? A plus I in LHS, what they have given, A plus I. So if I want to simplify A plus I, then these two eigenvalues along with 1 is the, see, if this is identity matrix of 2 cross 2 order, means the eigenvalues will be obviously 1 and 1, right? So adding those two values here, you will be getting lambda 1 plus I, lambda 1 plus 1, lambda 2 plus 1. Determinant means what? Product of the eigenvalues. If these two are the eigenvalues, then you have to product them. You will be getting this one. And in the right hand side, what they have given, 1 plus determinant of A. So consider that one. 1 plus determinant of A is equal to 1 will remain as it is. Determinant of A means we have considered lambda 1 and lambda 2 as two eigenvalues. So multiplying of those two eigenvalues. After that, equating these two, you will be getting lambda 1 plus lambda 2 is equal to 0. This is the condition for sum of the eigenvalues, which is nothing but trace. What we have got, 0. So trace of A is equal to 0 is the correct option. We should take the first option. Okay. So the next question is, if A is equal to 3 minus 2, 4 minus 2 satisfies the matrix equation A square minus Ka plus 2i is equal to 0, then what is K? They have given the 4 options. This is very easiest problem. See, from the given matrix, write down trace and determinant. Characteristic polynomial, already we know that x square minus trace of A into x plus determinant of A into 0 is equal to 0. Back substitute the values, simplify and comparing with the given equation. So K value will be 1. And here, in the next question, the dimension of the vector space of all symmetric matrices A is equal to Aij of order n. N they have given n is greater than or equal to 2. With real entries, A11 is equal to 0 and trace is 0. Okay. So first of all, whatever they will be giving the number as n is greater than or equal to 2, you have to select the basic number, that is n is equal to 2. If they have given n is greater than or equal to 3, then consider n is equal to 3 as your n. See, n is greater than or equal to 2, so we have considered n is equal to 2. They have given two conditions, right? A11 is 0 and trace is 0. Dimension of symmetric matrices for n cross n matrix is n into n plus 1 divided by 2. This is very, very important. This is a formula. Dimension of symmetric matrices of n cross n matrix is n into n plus 1 divided by 2. For skew symmetric matrices, n into n minus 1 divided by 2. Okay, n into n minus 1 divided by 2. So this is the formula, but in this problem, along with that formula, they have given two conditions, right? Along with that formula, they have given two conditions. So with the formula, you should subtract those two conditions. So you will be getting n square plus n minus 4 divided by 2. N square plus n minus 4 divided by 2. This is the correct option, that which is option number 1. Hope you people are following. If you have any doubt, please comment below. I'll reply to your questions or doubts. Let M3 of R be the set of all 3 cross 3 real matrices. If A belongs to M3 of R has 1 minus 1 1 by 3 as eigenvalues, then the eigenvalues of A power minus 5 are, they have given the 4 options. Same, very easy. Eigenvalues of A they have given, write it down. Eigenvalues of A inverse means you have to just reciprocal, right? Reciprocal of the given matrix, given eigenvalue. Then eigenvalues of A inverse to the power of 5 means you have to raise the power of these eigenvalues of 5. So what you will be getting? 1 power 5 is 1 itself. Minus 1 power 5. This is odd number 5, right? So minus 1. 3 power 5 is 243. So this is the eigenvalues of A inverse to the power of 5, which is nothing but A power minus 5. So easily you can get the solution. If you want to go through this definition, then this is the definition. Okay. So the last question of this series is, you have to check which of the following 4 matrices is not diagonalizable over R. So first one is 1, 2, 3, 0, 4, 5, 0, 0, 6. Clearly this is a upper triangular matrix. So the principal diagonal elements are the eigenvalues. And since these eigenvalues are distinct, therefore it is diagonalizable. But what they are asking, which is not diagonalizable. So this is correct, diagonalizable, but not our option. Okay. So consider the second one. 1, 1, 0, 0, 2, 0, 0, 0, 1. This is also upper triangular matrix. So the leading entry, principal diagonal elements are itself the eigenvalues. But directly we can't say that this is diagonalizable because eigenvalues are not distinct. For this type of problems, what you have to do, the second option is check for algebraic multiplicity and geometric multiplicity for each eigenvalues. That means for each eigenvalue, if lambda 1 is there, lambda 2 is there, and lambda 3 is there, then for each value you have to check AM should be equal to GM. Then only it is diagonalizable. Let's check further. See, at the end we will write this one. Algebraic multiplicity of lambda is equal to 1 is 2. Algebraic multiplicity of lambda is equal to 2 is 1. Algebraic multiplicity is nothing but how many times the eigenvalue has repeated. So to find out the geometric multiplicity of lambda is equal to 1, this is the formula. Substitute the lambda value, you will be getting this one. So before substituting to this, let me find this lambda of A minus I. First of all, we will find A minus I. So A means given matrix, I means the identity matrix. After simplification, you will get this. But as soon as simplification, you should not apply this formula. You should reduce this to row reduced echelon form by using proper row operations. Then you will be getting this matrix. For this matrix, you have to check the rank. Anyhow, this is the A minus I matrix, right? A minus I matrix. So the rank of this one is non-zero row, that is 1. So substitute now. N is nothing but the order of the matrix. Order of the matrix, which is 3. the given matrix is of order 3 cross 3. So 3 minus rank of A minus I, which is 1. So geometric multiplicity of lambda is equal to 1 is 2. We have seen algebraic multiplicity of lambda is equal to 1 is 2, and geometric multiplicity of lambda is equal to 1 is also 2. So this can be considered as diagonalizable if for the second eigenvalue also if we get am is equal to gm. But dear students, there is a shortcut tips for you people. If the element is only once, it is not repeated, means no need to check for am and gm, it will be equal only. Okay, just check for the elements which are, or the eigenvalues which are repeated. No need to check for the single element, always it will be same. So save your time, and this is the correct option. Okay, sorry, this is diagonalizable, but we are finding for not diagonalizable. So let's check for the third matrix, which is this matrix. Here see, all the eigenvalues are 0. That means what? The given matrix is nilpotent. The only eigenvalue is lambda is equal to 0, means the given matrix is nilpotent, and we all know that nilpotent matrix is not diagonalizable. Nilpotent matrix is not diagonalizable. These types of matrices you should be knowing, and also this type of statements, if you know, then you can directly tick the option and you can save your time. Okay, and the last matrix is constant matrix, and you people know that constant matrix is always diagonalizable. By using these statements, if you know very well about these statements, then you will be reaching the solution quickly. Okay, these are all the problems of 2024. Let's see, in the next video I'll be solving 2023 linear algebra questions. Okay, in that year also they have asked 11 questions out of 100 questions. So wish you all the best, dear students. If you have any doubts, please comment below. If you want to discuss, then we will discuss with the doubts in the next video. Thank you.